Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. Today, inshallah, we will continue on definite integration. I want you to remember the main rules of definite integration, which is really very simple. All you have to do is to integrate first, then substitute by the integration limits. By the upper limit minus the lower limit. You will get a value. Today, we will speak more about the meaning of definite integration. Definite integration in general, once you integrate a certain function with respect to x, it means you are finding the distance between, you are finding the area under this curve to the axis of integration. It stands also for y. If you are integrating x as a function of y with respect to the y-axis, you will be able to evaluate the area, but with respect to y-axis. You will know this down the road, inshallah. Not this semester, not with this module, but with the coming one, you will take more complicated problems in where you will have to start integrating with respect to y instead integrating with respect to x. But for the time being, we will keep our discussion for the simplest problems that will be represented for an area under the curve and the x-axis. It's very, very simple. All you have to do is to integrate the function starting from the lower limit to the upper limit. So, integrating from a to b f of x dx, it will give you the area under the curve from a to b at the shaded area, as you can see. There is some simple ideas actually between adding or subtracting areas, different areas between curves in order to get the area required for you. For example, if you want to have, let me try to illustrate these examples, these couple of examples or ideas. Ideas are really very simple. If you have, let's say, I have, this is the x-axis, that's the y-axis, and I have y equal to x squared, which is y equal to x squared. And if we have let's say x squared minus, say 2, this is 2, and we need to evaluate the area under the curve from x negative 2 to positive 2. All you have to do is to integrate just simply x squared minus 2 dx, starting from negative 2 to positive 2. So this is the area that you will get by finding this definite integration. We can do some manipulations. Instead of dealing with from negative 2 to positive 2, I can integrate from 0 to 2, which is going to be more simpler. Then multiplying by 2 for x squared minus 2 dx. And this way, you can get the value of this area, then multiply it by 2 to get the whole area. It means simply, we can manipulate whatever happens with areas in order to get the required areas that you are looking for. Another problem, if we have y, this is the x-axis, that's the y-axis. If we have y equal to x squared and we have y, let's say y equal to x plus 2 or something. So this is 2, and if we want to get the area between these two curves from these 2 points, you will have to work your magic. Simply, I will try to get the area under the straight line, which will give you a trapezoidal, minus the area under the curve, which will give you this part. Subtracting them from each other, you will get the required area. It's really very simple ideas. All of them is about how to get your area, either by addition or by subtracting these areas, as we will see down the road. Okay? Also, you have another very small idea. If the function that you are evaluating is go through, or the x-axis or the axis of integration go through your area, you will have to evaluate each part of it separately. Okay? And then you will add these areas. I believe in the previous time, I showed you something like this. You have from A, B, and C, and you want to find the area bounded by this curve and the x-axis, which actually represent these areas. And this problem is very, very important. You will have a couple of examples We will see them now while we are working in more examples. For this particular problem, you will have to get A1 first plus A2. I would recommend this method. Don't try to get the function from A to B minus integration of the function from B to C. I would prefer if you evaluate the area number 1, A1, plus the absolute of area A2, and put them all together. It's going to be simpler, less problems, and so on. So simply, if this is f of x, we can get the area required from A to C simply by integrating from A to B f of x dx, then plus the absolute of the integration from B to C for f of x dx, and you are all set. كده جبت الاريا بتاعتك. Okay, go.
Why absolute? Can area not be negative?
No, areas cannot be negative. Whatever you can touch with your hand, it's not gonna be negative. Okay. The negative value, it represents the direction. Okay, it always represents a direction, not the value by itself. When you are grabbing areas, you will get the area of A1 either by two ways. I'm talking about the whole area. You get the area of A1 minus the area of A2, which is going to be a negative value. So minus times negative is going to be positive, so you can add them together and get the result. In order to go out this idea about adding or subtracting or something like this, it's better to evaluate this part alone, then plus the absolute of the other one. That's it. You are getting A1 plus A2, the whole idea, or the whole area. If you integrate from A to C, the positive will eat some of the negative or vice versa, and you are not going to have your exact area evaluated correctly. Are you with me? Okay, perfect. تعالوا نبص على بعض problems. What we did go through is explained here. In case of f of x is a negative function, so once you integrate, f of x dx is going to be negative. When determining such areas by integration, a negative sign placed before your integral. This is what I've told you about. Look, for this problem, if I'm going to use this method, I will do the following. I will integrate from A to B, then minus integration from B to C, because the value is going to be negative. Then plus the area, the integration from C to D. You start putting positive and negative, or subtracting some parts of this integral. And instead of doing that, just simply evaluate the area between A and B, then plus the absolute value from B and C, then plus the area for G. So you add area E plus area of F plus area of G. I would recommend this method. Go away from multiplying a negative value or something. Just add them together. Okay.
Can we integrate the function from A to D?
No. What's going to happen if you integrate from A to D, the positive parts will be summed with the negative parts, and it will give you the overall result, positive and negative. Okay? So, for example, if this area was 2, and that area was 4, and that area was 5, if you, 3, I'm sorry. If you integrate from A to D, the result will be 1. He will add 2 plus 3 minus 4, which is not correct. While the actual value of this area is going to be 2 plus 4 plus 3. Okay? اتفضل.
احنا بدل ما نكتب ابسولوت فاليو ممكن نعمل نيجاتيف ساين خالص.
ما هو ده اللي انا بقوله بقالي ساعه.
هتفرق كتير ولا؟
مش هتفرق، تديك نفس الريزلت. بس انا مش عايزك تكتب النيجاتيف، انت تفكر وتحط النيجاتيف. احسب، لانها هتظهر complicated problems down the road. مش really very simple زي دي. فانت الرقم اللي هيطلع بالنيجاتيف اضربه في نيجاتيف. لا، الصح بقى ماشيه كله على بعضه، ان انا هاخد دايما الاريا بالبوزيتيف as an absolute value, and I will add them or subtract them. انا اتحكم في الاديشن ومين؟ والسبتراكشن. لان كمان شويه انت هيبقى عندك كيرف زي ده وكيرف تاني مرسوم معاه، وانا عايز اجيب الاريا ان بتوين. فهتبدا انت اللي تفكر when to add or when to subtract. Do you read me? Okay. طبعا هنا بيوضح لك بقى القصه دي اهو، حط نيجاتيف زي ما حضرتك بتقول. انا كل اللي انا بقوله على الميثود التاني، خلي ده بلس خد دي مالها ابسولوت. ذاتس ات. اوكي، انزل هنا بيقول لك determine the area enclosed by y which is 2x plus 3 and the x-axis. The coordinates from x equal to 1 and the x equal to 4. It's very, very simple. All I have to do, as I told you, all we have to do is to get the integration. First, I would recommend that you give a sketch for these functions in order to imagine the area that you are seeing. Y equal to x plus 3. How to draw a straight line? It's very, very simple. If we put x equal to 0, so y is going to be 3. So this is going to be 3. If we want to put y equal to 0, so x is going to be negative 3 over 2, which is going to be negative 1.5 over here. This is exactly the shape of your straight line. You want to integrate the area or to find the area between this straight line and the x-axis, starting from x equal to 1 up to x equal to 4. So actually we are seeking this area. In order to get this area, it's going to be really very simple. What's the curve that you are seeking to get the area beneath it till the x-axis? It's y equal to x plus 3. So all I have to do is to integrate from 1 to 4 for 2x plus 3 of dx. Now you can get the area very, very simple. It's going to be x squared plus 3x. Start substituting first by 4, then by 1. So you will end up having 16 plus 12, as I think, minus, I believe, 4. And so you will get your area very soon. It's very, very simple. This is the main idea about integration or definite integration. The main application is to find area. Remark that if you, and we already did go through this, I believe with the second unit of something, or first unit, I believe, about the volumes and the surfaces and so on. Once you have a surface area, or once you have an area, you can multiply by thickness, especially if you have constant thickness. So you will get a volume. If you multiply it in density, you will get a mass. So evaluating area is a very, very important application. Okay? روعة. انزل. الكلام ده طبعا موجود عندك اهو. ادي الاريا بتاعتي، ده الكيرف انا رسمته لك وعرفتك ليه هو من 1 ل 4 وهيبدا يعمل الحسبه ده. هنا بيقول the velocity v of about t seconds after a certain instant is given by v equal to over t squared plus 5 meter per second. So actually the velocity is a function in time. Find by integration how far it moves in the interval from t equal to 0 till t equal to 4. It's really very simple. You will have here two options. Either to graph your function, which I would deeply recommend in order to avoid if there is part of your function is above or below the x-axis. Graphing something like this is really, very simple, especially that we already have an idea, a very nice idea about how to graph quadratic equations. So I have v, which is going to be 2 over t squared plus 5. If you remember, this is going to be symmetric about the vx. And if you want t equal to 0, the vertex will be at 5. As you can see, the coefficient in front of t squared is positive, so it's moving upward. So actually, if you try to look at this function, it's going to be like this. This is t, this is the velocity that you are seeking. This is the function that we are talking about. This is the value, the vertex, which is at 5 in v, if you put t equal to 0. And he wants you to evaluate starting from t equal 0 till t equal 4. So actually, this is the area represented by integrating velocity with respect to time. All I have to do is simply try to integrate from t equal to 0 up to 4 for the function 2 over t squared plus 5 with respect to dt, and then you will get your s distance as as a number starting from 0 once you are moving from time 0 to t equal to 4. So simply it's going to be 2 over 3 of a t cube plus 5 times t, and then we will substitute replacing every t by 4 minus 0. See, when the lower limit is 0, it's very, very comfortable once you are, or very easy to evaluate, because simply you are going to substitute just only with the upper limit, and that's it. If you try to put t equal to 0, so it's going to be 0, so the final result is going to be 2 times 4 to the power of 3 divided by 3 plus, I believe, 20, and that's it. You will get your distance in there. Very quick, very smooth. Okay. The problem next to this one, it's really very nice. Okay. I've tried, for this function. Here he's giving you a cubic equation, sketching the graph of y equal x cubed plus 2x squared minus 5x minus 6. Because we didn't go through how to graph in specific cubic functions. In order to get a cubic function, you will have to get the roots of this function. Going through finding roots, it's not going to be an easy job to do. So he's helping you here, and he's asking you to sketch the area between x equal -3 and x equal 2. If this happens, I would recommend, deeply recommend, that you start substituting from -3 till you reach 2. So I will start substituting by -3, -2, -1, 0, and 1 and 2. Hoping that we are going to get some of them are zeros or 0 values. This way, I will be able to find in exact where the points that will cut the x-axis. Okay, if we try to draw this graph, so at x equal to -3, the value of y equal to 0. So at x equal to -1, the value of y equal to 0. And also at x equal to 2, the value of y equal to 0. Here are the 3 roots that you can find simply once you put x cubed plus 2x squared minus 5x minus 6 equal to 0, which is the intersection of this cubic function with the x-axis. This is mainly the point that represents a difficulty for this problem. I want to evaluate the area bounded by this curve and the x-axis. Any ideas how to evaluate it, Yusuf?
There, integrate.
Okay.
X power x4 over 4.
So the area is going to be integrating
X power
from -3 till
to
-1. From -3 till -1. This way, I will get this part of the function, which is between -3 and -1, which 4x cubed plus 2 over x squared minus 5x minus 6 was just equal to x. This is the area which is going to be evaluated. You have the option either putting a negative this value, or as I would prefer to do it, plus an absolute for an integration from -1 to +2 for the same function, which is x cubed plus 2x squared minus 5x minus 6. Then start integrating, which is really very simple. This one is going to be x to the power of 4 divided by 4 plus 2 over 3 over x cubed minus 5 over 2x squared minus 6 of x. Then I will substitute by -1, then -3 in a similar manner for the other value. It's going to be exactly the same function, which is x to the power of 4 over 4 plus 2 over 3 x cubed minus 5 over 2x squared minus 6 of x, but instead we will start substituting from 2, I will start substituting first by 2, then by -1 is enough. Okay? If we, once more, if you integrate for the same function, starting from -3 to +2, you are not going to get the same result. You are going to get the difference between these two areas. Okay? تمام. طبعا البروبلم دي already solved والresults already exist in Canvas, please try to resolve them again, especially that you will mark, the marks will be given for the final answer. طبعا هنا بيقول لك y dx integrated from -2, also y dx, you will replace y with your function. This is the details of the evaluation of these two functions, and this is the end result of this example. Okay, let's go through this problem also, but before going to this one, I would like to give you this problem, which is also very, very similar to the previous one, but it could be given like this. Find the area bounded will be find the area bounded by y equal to x minus 7 and x squared minus 4x, let's say block 3, at the x-axis. How to graph and how to go through a function like this. The main idea in getting a function, a cubic function like this one, is to identify the points of intersection of this function with the x-axis. So it's really very simple. Start to factorize this bracket. So it's going to be really x minus 1 times x minus 3, I believe, and this one is x minus 7, that's 1. It means x-axis, your function will cut the x-axis at 1, 3, and 7. So I will go through, this is the x-axis, that's the y-axis, the points are 1, then 3, then 7. How to sketch your function between them? This idea is very, very nice. All I have to do is to substitute by logic before and after each point of these points. So I will start with a point with this interval from -infinity till 1. I will choose just only one point. What's the ending point that will appear? 0. Start substituting with 0. 0 in this bracket will develop a negative number. 0 in that bracket, it will develop also a negative number. And also substituting, it will be negative. Negative times negative times negative. It means your function already exists in the negative part, or find here in the negative part. So once you get near to 1, it's going to be 0. Start to choose number between 1 and 3. Substitution is just only by logic. I will start to take 2. I'm guessing the function value will, or the y value will be a positive. Start substituting. 2 in this bracket is going to be negative. 2 in that bracket is going to be positive. 2 in that bracket is going to be negative. So negative times negative. So your function is going to be with the positive. It will make a U-turn and it will hit at 3. I believe between 3 and 7 is going to be negative value. Also in a similar manner. Start taking a number, just any number between 3 and 7. Let's say 4. If we substitute 4 here, it's going to be positive, but it is negative, which makes sense that the function is going to be in the negative part. Then it will move again once more to hit the x-axis and go up. If you want to be sure about this, try to take any number greater than 7 and simply by logic start substituting. Let's say for an 8 as an example. And this bracket is going to be positive. This bracket also will be positive. And the final one will be positive. So that the function actually will go this way. He needs you to find the area bounded by this curve and the x-axis, which represent the areas that will appear here. This one, plus the other one, which is here. So simply, in order to evaluate the area, I will simply try to find the value of y. So try to expand it. Y will equal to x times x squared, which is going to be x to the power 3, x times -4 of x, so it's going to be -4x squared. This is going to be -7x squared, so you will end up having -11 of an x squared. This is going to be 3 of an x, and this is going to be 28 positive of x, 3 plus 28, which is going to come up to, I believe, 31. So this is going to be plus 31 of x. Finally, 3 times negative 7, which is negative 21. This is the value of your function. So I will integrate first from 1 to 3 for the function, which is simply x cubed minus 11 of an x squared plus 31 of x minus 21 dx, then minus the integration from 3 up to 7 for the same function, which is x cubed minus 11 of an x squared plus 31 of an x minus 21 dx. The integration is very, very simple, because integrating this function will develop x to the power of 4 divided by 4 minus 11 divided by 3x cubed plus 31x squared divided by 2 minus 21 of x, and then you will start substituting by the integration limit, which is 3 and 1, and for the other part, which is going to be 7 and 3, and you will have your area. This method about how to sketch a function is really, very important. And the first chapter we will go through in the fourth module, or in the level 4 module for you in GK mathematics, it will be how to graph functions, speculate, sketch for some of the very, very famous functions, either rational functions or quadratics or straight lines. We will take the normal forms of all of these functions. And it will be very easy for you to just try to sketch these functions. Okay, for this one, he is asking you to find the area enclosed by the curve y equals sine 2x, and the x-axis. The coordinates will run from 0 up to pi over 3. The problem with the trigonometric functions is you will have to try to sketch this function in order to imagine how are you going to evaluate your area. Are you going to evaluate the area once and for all, one time, or you will have to separate your integration limits into 2 parts. If the x-axis separate your graph, some of the function already exists in the upper part, and another part of it within the negative, so we'll have to do what we did in the previous examples. معايا يا شباب؟ حضراتكم متابعيني؟ يبقى أنا لازم أرسم. First of all, try to identify the mean period. The mean period for any sine functions. How it's going to be? The ideal one or the mean one. If y equal of a sine x, the function will go like this. This is x, that's y. The angles will move from x equal to 0, then it will increase till pi over 2, then will decrease once more to catch 0 at pi, then it will go to negative at 2 pi over 3, then will go also to positive at 2 pi. These are the critical functions, the critical angles, 360, 270, 180 or pi, and this is pi over 2. The main period here is 2 pi. Remark, if I want to graph y equal sine over 2x, that means for the whole period, 2x will equal to 2 pi, that's x will equal 2 pi in order to get a full period for this function. It means that your function is gonna be, this is the x-axis, that's the y-axis, so the sine function will be exactly the same, but then the whole period it's not going to be 2 pi, it's going to be simply pi. So instead of having this as a 2 pi, this is going to be pi. The middle will be pi over 2. This is going to be 3 pi over 4, and at the middle you will have pi over 4. So actually, manipulating the angle by numbers is going to affect on the mean period in the trigonometric function, of your trigonometric function. Either sine, cosine, whatever.
I thought y equals sine x period is pi because it intersects 0 at pi intervals, not 2 pi.
No, it will intersect at 0, pi, and the 2 pi. So the main function or the main period is going to be the whole cycle starting from x equal to 0, from the angle 0 till the angle 2 pi, or from angle 0 till angle 360. This is the whole cycle of degrees. مش انت عارف ان الديجريز بتاعتك degrees that start from theta equal to 0, and it will increase, and will go till it reach 2 pi, which is 360.
Yeah, but the period...
The period is going to be 2 pi. In order to have a positive part and the negative part for your function. 2 pi stands for 360 in degrees. And the grades and the degrees will go for a whole cycle, starting from 0 till it will have a full cycle, which is going to end at 360. So the main period is 2 pi, not pi. Pi is a half period for the sine function. Okay, perfect. You have to understand the effect of multiplying or dividing the angle by a certain value. See, if we multiply by 2, what's going to happen to your period? It's going to decrease. Okay? So this one decreased, you will get the half period if you multiply by 2. If you multiply by 3, it's going to be 1/3 of the main period, and so on. Okay, you want you to evaluate from x equal to 0 actually to pi over 3. Pi over 3, I believe it's going to be something like here. Pi over 3, which is 60, pi over 4, which is 45. So actually we are seeking this area. So simply, all you have to do is to just integrate sine 2 of x dx, starting from x equal to 0 till you reach x equal to pi over 3, you will get your area. Here we don't have to change to radians. We can use the main functions by degrees, but remark that pi over 3 stands for 60. So all I have to do is to simply integrate, which is going to be negative, over cosine 2x divided by 2. This is the integration of sine 2x. Then I will start substituting from 60, then 0. So if you try to do this, so it's going to be cosine of 2x, which is cosine of 2 times 60, cosine 120. And I believe the cosine within the second quarter is going to be negative. Yes, I believe. So you will have for this one 1/4 minus, if you substitute by 0, so it's going to be a half or something. Then try to get, okay, then try to get the difference between them. Once more, if you substitute by 60, it will develop negative sign. Negative times negative is going to be positive. Then minus, if we try to substitute, so it's going to be a positive value. This value is going to be 3/4 of an L square for this area. Remark, if I want to integrate to 5 pi over 3, for example, 5 pi over 3, it's going to be here. So you will have to separate your integration. You have to integrate this cycle alone. So integrating from 0 to pi over 2, then plus integration from pi over 2, or minus integration from pi over 2 till 5 pi over 3. حضرتك فاهمين انا بقول ايه؟ هنا انت عملت integration لغايه pi over 3 بس which exists in the first cycle صح؟ في البوزيتيف 1. لكن لو انا كنت غيرته لك بدل pi over 3 خليته لك 5 pi over 3, that means ان في جزء من النيجاتيف بارت هيدخل معاك صح؟ وبالتالي لازم احسب ده لوحده بلس بلس لو تاخد ابسوليوت يعني الاريا اللي موجوده تحت، او لو هتحسبها من غير الابسوليوت يبقى هتحسب الاريا اللي فوق ماينس الاريا اللي موجوده في الاذر بارت اوف يو with respect to your x. اتفضل.
How would you integrate sine 2x?
How to integrate sine of x first? Integrate distributive.
Negative cos.
Negative cosine of x. Okay. If I want to integrate sine 3x, the integration will be negative cosine 3x divided by 3 plus a constant. That's for the indefinite integration. Why? Because if you remember, we already did go through this in the previous session. Sine f of x under the condition that f dash x exists, this is how you can integrate. It's going to be negative over cosine of an f of x plus c. You can't do this result except once you have the derivative of your angle. ده condition عشان تعمل integration. لذلك ضمنيا مستر خالد sin 3x الانجل الديريفاتيف بتاعها بكام؟ لذلك انا رحت عامل هنا 3 وبره ضربت في 1 over مين؟ 3. The 3 sin 3x all together is the negative cosine 3x. And you will have a remainder which is 1 over 3. It will remain here. In order to check your result, please start differentiating this function. Differentiate once more. So it's going to be negative over sine 3x. صح? Negative times negative is going to develop sine 3x. Times the derivative of the function, which is, it will find 3 in the denominator waiting for it to appear. They will cancel each other and you will have the same function that you are integrating. So, bottom line. If I want to integrate sine 2 of x dx, the integration will be negative cosine 2x divided by 2 plus cos. If I want to integrate sine 5x, similar manner. So it's going to be negative cosine 5x divided by 5. So if I want to integrate sine x over 2, حد يقدر يقول ايه؟ sine x over 2. It's going to be negative cosine of an x over 2, but don't you forget times 2. Okay, and so on. This is very, very vital. You can't integrate once more, Yusuf. You can't integrate unless these conditions are satisfied. This was your question in the previous session, and this is the question that we started today before our lecture, and here once more. Okay? Okay. We can go through it together later. Okay, perfect.